Hello, welcome to TQS. In this video, we will present the resources available in TQS for projects developed in BIM. In short, BIM is a multidisciplinary modeling concept in which objects are geometrically represented in 3D and with attributes. Each discipline is responsible for its own modeling, and the information must be available to everyone. BIM does not require everyone to use the same software, but communication between the software programs should occur in the best possible way. In the case of structures, the information that should usually be included in the BIM model is the structural elements, with their respective geometry and material. Both the main structural elements and those that are not part of structural integrity must be modeled. BIM is increasingly becoming mandatory by contract. In addition to the formwork and reinforcement drawings, the engineer is required to deliver a BIM model of the structure. In addition to providing structural information, BIM also allows engineers to benefit from information from other disciplines, such as importing and using 3D architectural models as a reference, transforming walls into loads, importing pipes, and generating holes in the structure. In TQS, one way to exchange information with other software is via plugins. TQS provides plugins for communication with Revit and Tekla. The TQS plugin for Revit, for example, is a program that runs within Revit with commands for synchronizing the model with TQS. Our plugins are available for download on our website and are completely free. One of the operations that the plugin provides is the import of the structure model generated in TQS into Revit. It does this using families and parameters as if they were created in Revit itself, but automatically. Another feature of the plugin is the export of the Revit model loaded into TQS. In this case, the building is automatically created in TQS, and the imported model can be used as a reference. If the model in Revit contains plumbing, electrical, or air conditioning piping, TQS can interpret these elements and present a collision report with the structure. Through drilling criteria, TQS also allows for the automatic generation of holes to resolve collisions. This drilling can be performed globally or item by item, with complete control by the engineer. If the model in Revit contains walls, TQS allows for the automatic transformation of these walls into loads, considering the wall dimensions and a weight per square meter table filled in by the engineer. If the model in Revit contains structural elements, TQS can interpret them as long as the TQS modeling limitations are met. Besides plugins, another way to exchange information in TQS is through IFC, which is a software-independent file. Currently, the main software programs that work with BIM can read and write files in IFC format. TQS has a command to export the structure in IFC format. This file can be read by major market software such as ArchiCAD, Solibri, and Revit itself, although in the latter case, the use of the plugin is recommended. In an IFC file, the same model can be described in different ways. This can cause the file to become larger or smaller and may affect compatibility with other software. In TQS, it is possible to configure various export options. TQS also has IFC file reading functionality that can be used to create a building in TQS, bring in a 3D model with attributes as a reference, transform walls into loads, and interpret pipes for collision checking, in the same way we discussed earlier for plugins. TQS has a graphical editor for creating and editing 3D models called EAG 3D. With it, you can create generic solids to complement the 3D model of the structure, refine a 3D model of the structure generated by TQS using operations between solids, and edit the 3D model of other disciplines. With EAG 3D, the BIM model of the structure can be created and refined entirely in TQS without the need for other software. TQS allows the creation and reading of BCF files. BCF is a file that allows for the creation of dialogue between disciplines by cataloging a list of notes that need to be reviewed. Each entry in the BCF file includes, for example, an explanatory text of the problem, the elements that need attention, and an image that highlights what is being pointed out. Upon receiving the BCF file, the other software will display the list of points. When one of the items is selected, the camera will move to the point location. The inquiry can then be answered, and the BCF can return to the sender with the answers or continue the dialogue. In TQS, when checking for collisions with piping, each collision with the structure automatically generates a record that can be resolved or exported to the BCF file. All structural typologies available in TQS, including cast-in-place concrete, precast concrete, and structural masonry, can be exported via IFC plugins. Exporting reinforcement for cast-in-place and precast concrete buildings is possible, but it can load the model, so exporting the reinforcement box as an attribute is usually sufficient. To learn more about TQS, visit our website. Thanks.